So in this lecture, I would like to discuss the second method for the separation of the lanthanones, that is solvent extraction method. Solvent extraction method. So what is the solvent extraction method? With the help of the proper solvent, the lanthanones are extracted from one phase into the other phase. As like of the ion exchange method, the lanthanone ions are distributed into the two phases. In this method, with the help of the proper solvent, the lanthanone ions are extracted from one phase into the other phase. So solvent extraction method is one of the modern method. Solvent extraction method is the one of the modern method of separation based on the distribution of substance between the two immiscible liquids. In this method, we have to take the two immiscible liquids. Two immiscible liquid means they are not soluble to each other. Two immiscible liquids. For example, ether is an organic solvent and water, both are totally immiscible. Or carbon tetrachloride, it is an organic solvent. Water, it is aqueous. So both are totally immiscible with each other. So solvent extraction method, it is based on the distribution of the substance between the two immiscible liquids. In this method, an aqueous solution of an substance is brought. We have to take the solution of the lanthanone ions in aqueous phase. So in this method, an aqueous solution of an substance is brought in contact with organic solvent, so as to bring about the transfer of solute into the other solvent. The solute can be extracted from one phase into the other phase here. Solute means the solution of the lanthanone ions. Okay. The substance that is extracted into the other solvent, it is later on recovered by evaporation. It is later on recovered by evaporation. So in this solvent extraction method, you can see here this diagram. This is the separating funnel. Okay. So in this separating funnel, we have to take the two solvents, organic solvent and suppose water solvent, aqueous solvent, and we have to add the solution of the lanthanone ions here. Solution of the lanthanone ions in the separating funnel. Okay. We have to add the lanthanone ion solution. So what happens here? The lanthanone ions are distributed into the two phases. Suppose this is aqueous phase and this is organic phase. Or in this case, it is an organic phase and it is an aqueous phase. Depends upon the molecular weight of the solvent. Okay. So generally the lighter phase, it is above, and the heavier it is at the below. If the organic solvent, it is having higher molecular weight, then it should be at a lower level. Okay. So in this way, the lanthanone ions are distributed from one phase into the other phase here. And both the phases are liquid phases. Both the phases are liquid phases. Organic solvent as well as aqueous solvent. So the solution of the lanthanone ion in aqueous phase, it is added into this separating funnel, and the lanthanone ions are now distributed into the two phases. Just like in ion exchange method, the lanthanone ions are distributed into the solid resin and in aqueous phase. So in this case, the lanthanone ions are distributed into the two phases, that is organic solvent and aqueous solvent. Okay. So let us see what is the solvent extraction method now in detail. Which type of the solvent can be used here for the solvent extraction method? Okay, which type of the solvent it is used in the solvent extraction method? So you can see here, see, we require what? A separating funnel. I would like to show diagrammatically the separating funnel here. So this is a separating funnel. Okay, you can see here. So in the separating funnel, we have to take organic solvent. We have to take a organic solvent here. Okay. Because we in the organic solvent, the ions can be extracted from one phase into the other phase. Okay. See here. So let us take the organic solvent here. Suitable organic solvent. Organic solvent. Then we have to add equimolar solution of lanthanone ion. Aqueous solution of lanthanone ion. Okay. What happens here? And later on we have to mix up it. We have to shake it. We have to shake it. After the shaking, the two layers are same. The two layers are same. Okay. The lower layer, it is supposed to be organic layer here, and the upper layer, it is aqueous layer. Upper layer, it is a aqueous layer, and lower layer, it is called as a organic layer, where organic solvent is there. And these two organic solvents are completely immiscible. So lanthanone ions are extracted from aqueous phase into the organic phase. That is, lanthanone ions are distributed into the two phases. Lanthanone ions are distributed in two phases. Distributed in two phases. That is, organic phase and aqueous phase. Organic phase and aqueous phase. In this way, the lanthanone ions are extracted from aqueous phase into the organic phase. But in the solvent extraction method, proper selection of the solvent is very important. Proper selection of the solvent, it is very important here. So particularly in the solvent extraction method, the organic solvent plays a very important role. So the organic solvent which is used here in the separation of the lanthanone, it is a tributyl phosphate, TBP. This solvent, it is used here, tributyl phosphate. Okay. Now this is the most suitable solvent. It is the most suitable solvent for the separation of the lanthanone. Why TBP is used as a solvent? Tributyl phosphate. Why not other solvents? Carbon tetrachloride, ether, methanol, or other solvents we can use here, organic solvents. But that solvents are not suitable. Proper separation of the lanthanone is not possible. So to enhance the separation of the lanthanone and to get the proper separation factor alpha, in this case also the separation factor alpha plays a very important role. Later on we are going to derive the derivation of the separation factor alpha. But first of all, I would like to explain here how the lanthanone ions are extracted from aqueous phase into the organic phase. So tributyl phosphate, it is used as a solvent here. So why TBP? Why TBP is used as a solvent? First important thing is that it is easily diluted with kerosene. It is easily diluted with kerosene. Okay. It means we can use here kerosene also. Why kerosene? Because the cost of the kerosene, it is less. TBP is a very costly solvent. Tributyl phosphate, it is a very costly solvent. So we cannot use large quantity of the TBP here. Otherwise, the separation of the lanthanone becomes very costly. So therefore, the diluted solution of the TBP can be used. So to dilute the TBP, kerosene can be used here. So TBP is easily diluted with kerosene. This is one important thing. Second, it resists oxidation. It resists oxidation by nitric acid. Because in this case, in the separation of the lanthanone by solvent extraction method, we can use nitric acid solution of lanthanone ions. It means that solution is prepared in nitric acid. Okay. So nitric acid, it is a oxidizing agent. So it will oxidize the organic solvent. But TBP does not oxidizes in presence of nitric acid. It resists oxidation by nitric acid. And third thing, it gives proper separation factor. It gives proper separation factor. So this is the 3 points where the lanthanone, the TBP can be used as a solvent. Okay. So you can see here, why TBP? Tributyl phosphate extraction, TBP. Why TBP is used as a solvent here? Okay. Solvent extraction technique is used for the separation of lanthanides from each other by extracting lanthanides into TBP. Lanthanides has to be extracted into the TBP, tributyl phosphate, from aqueous nitric acid solution. It means that we have to take aqueous nitric acid solution here. Aqueous nitric acid solution here. Okay. This aqueous nitric acid solution. So TBP is selected as a suitable solvent for the separation of the individual lanthanide ions. This is because it is very efficient in nitric acid medium. It is very efficient, means TBP is very efficient in nitric acid medium, and it also resists oxidation by nitric acid. It also resists oxidation by nitric acid. It means it cannot be oxidized in presence of nitric acid. Second thing, it brings out higher distribution coefficient value. Okay, higher distribution coefficient value, that is lambda value. And it can be diluted with kerosene without lowering efficiency. We can use here kerosene as another solvent, because TBP, we cannot use the pure TBP as a solvent here because the cost of the TBP is very high. So we have to dilute that kerosene without lowering the efficiency. Now, how the extraction is carried out? Okay, we know why TBP is used as a solvent. These are the 3 points, 3 reasons where TBP can be used as a solvent here. Now, what is the method? When a nitric acid solution of lanthanone is treated with TBP in kerosene, the lanthanone form neutral complexes. and get extracted into organic or non-aqueous phase, and this equilibrium is established here. So we have taken here nitric acid solution of the lanthanone ion. Okay, nitric acid solution of lanthanone ion. This lanthanone ions and nitrate ions are there. Okay, and that solution, it is added into the tributyl phosphate as an organic solvent, and this complex get formed here. This is a complex. So in this case also complex formation processes takes place. Okay, tributyl phosphate, it is a ligand. It is a ligand, and nitrate ion, it is also the ligand. So this complex is formed here in the organic phase. The distribution of lanthanide ions between the aqueous and organic phases depends upon the value of the distribution coefficient lambda for lanthanone ions. Okay, so once again, let us show this by diagrammatically. See, in the separating funnel, we have to add nitric acid solution of the lanthanone ions. Nitric acid solution of lanthanone ions. Okay. Initially, we have taken here TBP as a solvent, tributyl phosphate. It is organic solvent, very good solvent, and we have to add here nitric acid solution of lanthanone ions. Okay, nitric acid solution of lanthanone ion here. Nitric acid solution, that is aqueous solution of lanthanone ions. What happens? Lanthanone ions are extracted from aqueous phase into the organic phase. So this equilibrium is established. This equilibrium is established here. Nitric acid solution, 3 molecules, 3 nitrate ions. This is in aqueous phase. This is in aqueous phase. And tributyl phosphate as a solvent. This is in organic phase. And the lanthanone ions get extracted from aqueous phase into the organic phase. So this complex get formed in the organic phase. Okay, this is the complex. So in this way, in this organic phase, this complex is formed. Suppose that the first lanthanone ion which is extracted here, it is supposed to be lutetium tripositive ion, because it is having the smaller ionic size. Lutetium tripositive ion, all of us know, it is having smaller ionic size. Okay, so it is going to extract it first, and it is going to form the complex with the TBP and nitrate ion. Later on, we have to collect this fraction here. The two layers are seen. By simple elution process, we can collect this fraction here. Okay, so one suppose first complex that is collected here, that is for the lutetium tripositive ion. Again, we have to add the fresh volume of the TBP in this separating funnel. Suppose in the first step, we have taken, suppose assume 20 ml of TBP, and we collect that fraction after shaking, continuous shaking. The lanthanone, which lanthanone is extracted here? Lutetium tripositive ion, because it is having the smaller ionic size. So it is going to form the complex. It is going to form the complex. Okay. So lutetium tripositive ion, it is going to form the complex. So this complex will be formed here. Later on, we have to repeat the process. Then second extraction. Again, we have to take the 20 ml of the TBP here. Then shake the solution. Now in the second step, ytterbium tripositive ion can be separated. Okay, ytterbium tripositive ion can be separated. In this way, one by one, all the lanthanum ions are separated. And the last fraction which is collected here, it is belongs to lanthanum tripositive ion. At the last, the lanthanum tripositive ion, it is going to form the complex, and we can collect the fraction. In this way, the individual separation of the lanthanum ion, it is takes place here. Okay. So when a nitric acid solution of lanthanum ion, it is treated with TBP in kerosene, the lanthanum forms neutral complex and get extracted into the organic or non-aqueous phase. So this complex is formed here. Okay. The distribution of lanthanide ion between the aqueous and organic phase depends upon the value of the distribution coefficient lambda for lanthanum ions. Because lanthanum ions are distributed into the two phases. One it is the aqueous phase and another it is the organic phase. So let us see here. Lambda it is equal to concentration of lanthanum ion in organic phase divided by concentration of lanthanum ion in aqueous phase. So lambda it is equal to in organic phase the complex is formed here. This complex in organic phase, what happens here? The lanthanum, this complex is formed here. Already this is the complex which is formed in the organic phase. Okay, which is formed in the organic phase here. So concentration of the lanthanum in organic phase, that is complex, divided by concentration of the lanthanum in aqueous phase. This is known to as distribution coefficient. This is for one lanthanum ion. Suppose that it is for lanthanum, and it is for now next lanthanum ion, it is cerium. Similarly, for the other lanthanum ion, Ln dash, lambda dash, it is equal to concentration of the next lanthanum complex. Now we can calculate the separation factor alpha here, lambda dash upon lambda. So lambda dash divided by lambda here. Okay, alpha it is equal to lambda dash divided by lambda here. So we can put the values. So we can write this equation now. Concentration of the next lanthanum complex divided by concentration of the first lanthanum complex multiplied by concentration of the first lanthanum in aqueous phase divided by the concentration of the next lanthanum in aqueous phase. So in this case, an average separation factor 1.5 is reported for adjacent lanthanide ions in 15.8 molar nitric acid solution. What is the value of the separation factor alpha? 1.5. What is the concentration of the nitric acid? Very high concentration, 15.8 molar, very high concentration here. 100% TBP system. Okay, TBP should be 100%. So this separation factor alpha has been reported. Now we can apply the law of mass action to the complex formation process. Previously we have written the complex formation process, that is lanthanum tripositive ion, then 3 nitrate ions, then TBP, okay, tributyl phosphate, it is into the organic phase, and this complex will be formed here. Okay, lanthanum nitrate thrice and TBP thrice, and this complex it is formed into the organic phase. So we can apply the law of mass action to this. Then we can determine the stability constant or equilibrium constant K. So stability constant K, it is equal to stability constant of the complex K, it is equal to concentration of the concentration of the product, that is the complex. So concentration of the lanthanum complex, concentration of the lanthanum complex divided by the concentration of the reactant. So concentration of the lanthanum ion in aqueous phase multiplied by concentration of the nitrate ion. 3 nitrate ions are there. So concentration of the nitrate ion raised to power 3 multiplied by concentration of the TBP. 3 molecules are there, so raised to power 3. So we are getting this equation. You can see this equation here. Stability constant K, it is equal to. But what happens here? Or once again, I would like to show this. 1 minute. Okay, see here. Let us write here complex formation process. Lanthanone ions are extracted from aqueous phase into the organic phase. So this reaction, it is takes place. Okay. This complex, it is going to form neutral complex, supposed to be. This complex, it is formed there, that is known to us. So we can apply the law of mass action to this. So stability constant K or equilibrium constant K, it is equal to concentration of the complex. Concentration of the complex into the organic phase divided by, this is concentration of the lanthanone ions in aqueous phase multiplied by concentration raised to power 3 of the nitrate ion. Nitrate ion, it is from nitric acid, multiplied by concentration raised to power TBP. Okay. So this is in organic phase. So we are getting here the stability constant K. But now we know that the distribution coefficient lambda, it is equal to concentration of the lanthanone in organic phase, complex in organic phase divided by concentration of the lanthanone in aqueous phase. So this is lambda here. It is lambda here. So we can write here lambda divided by concentration raised to power 3 nitrate ion multiplied by concentration raised to power 3 of the tributyl phosphate. Okay. K, it is equal to, this is K, it is equal to stability constant K equal to. Therefore, lambda, it is equal to K into concentration raised to power nitrate ion multiplied by concentration raised to power TBP. Okay. So it means that this distribution coefficient value depends upon what? Concentration of the nitric acid, concentration of the tributyl phosphate. Okay. And it is also depends upon the stability constant of the complex. It will depends upon the stability of the constant of the complex. So see here the equation. You can see here lambda, it is equal to K into this. Okay. See this step. Concentration raised to power 3 nitrate ion multiplied by concentration raised to power 3 TBP in organic phase. So when we plot the graph of lambda versus concentration of the nitric acid, when we plot the graph here, lambda versus, means according to this equation, let us write once again that equation. Lambda, it is equal to K into concentration of nitrate ion nitric acid multiplied by concentration of TBP tributyl phosphate. Okay. So you can see here when we plot this graph of lambda, means log to the base 10 lambda, taking logarithm on both sides, and here concentration of nitric acid, concentration of nitric acid. Such type of the graph is obtained here. 100% TBP system, 100% tributyl phosphate, it is used here. So for the above equilibrium, when log lambda is plotted against concentration of nitrate ion at fixed concentration of TBP, it is fixed here. We cannot change this. What we are changing? Changing the concentration of the nitric acid. Okay. So at fixed concentration of TBP, a straight line with slope 3 should be obtained. A straight line like this. You can see here. This straight line, it is for ytterbium. This is for erbium, dysprosium, gadolinium, neodymium. Okay. So a straight line with slope 3 should be obtained. The slope of this straight line, it is equal to 3. Slope 3 is obtained about 10 molar nitric acid. You can see here 10 molar. Concentration of the nitric acid, it is 10 molar up to 15 molar. From the graph, it is also clear that the extent of separation increases with decrease in ionic radius. Extent of separation increases with decrease in ionic radius. Means the smaller lanthanide ions are having proper separation as compared to this. You can see the nature of the graph for neodymium. It is just like not a fully straight line, but for ytterbium, erbium, it is likely to be the straight line here. Neodymium, then for suppose it is for lanthanum here, cerium here. So we can say that the extent of separation increases with decrease in ionic radius. Okay. So in this way, lanthanum ions are extracted from aqueous phase into the organic phase, and their separation factor alpha value will be higher here. It will be higher here. You can see the distribution coefficient value will be higher, indicates that the separation factor alpha will be higher. So in this way, with the help of this solvent extraction method, the lanthanum ions are extracted from aqueous phase into the organic phase. So we have to take here nitric acid solution of the lanthanum ion. Concentration of nitric acid, it is around 15 molar nitric acid solution, and 100% TBP it is used here, tributyl phosphate. It means the concentration of the TBP, it is constant. So when we plot the graph of this log lambda versus the concentration of the nitric acid, we are getting the proper separation factor here for smaller lanthanum ions, means for lutetium, ytterbium, erbium. Okay. So in this way, lanthanum ions are extracted from organic phase into the aqueous phase into the organic phase. So which are the important steps involved in the separation of the lanthanum? Once again, I would like to repeat this. Important steps which are involved in the separation of the lanthanums by solvent extraction method. First of all, it is selection of solvent. Selection of solvent. Those solvents who are giving proper separation factor alpha, that can be used. Proper distribution coefficient, that can be used here. Proper distribution coefficient, that solvents can be used here. Okay. So the solvent which is used here, that is TBP, tributyl phosphate. It is used here in the solvent extraction method. Now this solvent extraction method is based on Nernst partition law. Solvent extraction method, it is based on Nernst partition law or Nernst distribution law. What is this law? The concentration of the solute in two immiscible solvent is constant at constant temperature. Concentration of solute in two immiscible solvent. We are using the two immiscible solvents here. Two immiscible solvent is constant at constant temperature. That is the Nernst partition law. And solvent extraction method, it is based on Nernst partition law. This law is also very important here. Okay, it is depends upon Nernst partition law. So we can write here the distribution coefficient D, it is equal to C1 upon C2. Okay, it will be constant. It will be constant here. So in this way, the lanthanone ions are extracted from aqueous phase into the organic phase. And the proper separation of the lanthanone ion takes place here. So this is the tributyl phosphate extraction method. Why TBP is used? Because it is very efficient in nitric acid medium, and it also resists oxidation by nitric acid. It brings out higher distribution coefficient value. It can be easily diluted with kerosene. So this complex formation process takes place here. Lanthanone ions are extracted from aqueous phase into the organic phase, and in organic phase this complex will be formed. And in this way, one by one, the lanthanone ions are extracted from aqueous phase into the organic phase, and they are separated. We can separate the layer, and by evaporation process we will get here the required lanthanone ion. So this is about the solvent extraction method for separation of lanthanone ions.